So I thought I start with an easy scenario that we actually have in our company. One of our department is scanning all of our AWS accounts and all our AWS stuff, and everything what they find, what is not okay or what's coming up, they push it to an S3 bucket. And to use that information, which is based in a very long JSON on a S3 bucket, we decided to implement an easy converter in Rust and build and deploy everything as a Lambda function, and the pipeline is written in Dagger with Python. Yeah, the deployment is handled by CDK. So we made a lot of things like define the CDK stack, build up the images that we really need, and the pipeline written in Python. The interesting part, in my opinion, was the learning curve to understand, okay, we all changed our laptops, so now we have a new Apple M1 and M2 chips. And the AWS Lambda function runs with based x86 chip. So yeah, we thought about, okay, is it possible to run this this Lambda function written in Rust after building with our chips? So to make that possible, we had to cross-compile our code so that is running on an x86 chip. And to be honest, it was a hard learning curve on that, on the first part, but now we are really good on that, and we fully understand that, and we can build and deploy our Lambda function actually, yeah, out of the box. And we improved our pipeline and our images on that also. So let us dive in. Yeah. That is our basic main function in Rust, written in Rust. It is not very complicated. I mean, we read a S3 bucket, convert some kind of stuff with the relevant information from the JSON, and write the converted data also back to another S3 bucket. So that is not a really interesting part, in my opinion. We defined the Lambda stack in CDK. So what do we have? Yeah, we have this function that's called the stack converter, and yeah, here we have the asset that we have to use, the x86 chip. So that is pretty easy for us. But to get everything up and running, we with Dagger, we started to write an orchestration, or a little orchestration in Python. So here we start with the run pipeline, and this is doing, or this is pretty straightforward. So we build our client and cross-compile everything based on Rust. We made a short check if the return value is really valid. So if the compilation fails, we don't get any file from the cargo compiler. And then we make the deployment. And if the exit code is is 0, then everything is fine for us. And not, then yeah, we have a problem there and we have an error. Yeah. So let us have a view on the build part. So first, I would say it's pretty straightforward. So if I have a look on Kyle, it means yeah, it's for him is very easy, I believe. But for us, it's a first step in the right direction. So what do we do here? We load the Rust Lambda base image. I will show you how we built this up. We setting we mount the directory, we're setting the working directory, and here we execute the cargo build or the cargo compilation for Rust with the target for an x86 chip. Yeah, that is if as we understand it completely, we know, okay, it's really cool and it's working now, but to get there and to have everything on your machine and everything is running in the right direction, it was a little bit hard. Yeah, and to get it on a CDK part, we have to copy some kind of stuff, but it's pretty easy. And yeah, here we have to check if the bootstrap file was really created. And I mean, that is the cool stuff on Dagger. First, here we make the compilation part, and we don't, and we check in our preferred language, in this case Python, if the compilation was really successful. In the deployment part, it's more straightforward in my opinion, because here we check in a first step, okay, are the environment variables there? And if not, then we have an error, okay. But if they are there, we take everything, we install everything, and then we call CDK out of the box and push everything to our AWS account. And after that, we have a Lambda function written in Rust, up and running, and that consumes or is triggered out of the box by every time S3 item is packed on the bucket. So that is pretty cool. In my opinion, it's really nice for us. And I also made this little example to get everything up and running in GitLab also. So if we execute this part on our local machine, everything is working really fine. And that is great, because that brings us in the situation, don't do feeling like 50 fixed commits on that, and go around to unsecure our branch or something like that. So, or to push force, yeah, we only can develop it on our local machine, we push it or commit it one time, and then we know, okay, it is running, and that is pretty amazing. And our GitLab file is, to be honest, it's really, really short. And it's no rocket science anymore. Yeah, it's really easy. It's easy to understand, and it could be for other use cases in our company. We can like standardize such kind of implementations for the future. So that is amazing for us, because we can now create such kind of GitLab files out of the box based on a template, and don't have to care about if it will run or not, because the rest is coming from the Python code. That is pretty cool. So let me execute this part to see that. Fingers crossed. Yeah. Okay, it's running. That is amazing. So in the meanwhile, I will switch to our base project where we build the Rust Lambda image, which we're using for this. And why is that important for me? Because we, as I mentioned before, we have different kind of platforms. Actor, we are working on a ARM64 chip architecture, and the Lambda function expects an AMD 64. So that is, yeah, it's curious, okay? And we have to find a solution on that. I mean, you know, Docker use the image that is running on your machine. So what we did, I mean, it's pretty straightforward. So we defined an array here with the architectures that we actually have, or that we really use or we need. We build up our base Lambda Rust image here. So we have everything installed in this one image, like the cross-compiling part here, or we have to set some kind of environment variables, which are really straightforward, and you can always use the same one. And after that, we push the both images to a Docker hub, and we have all available. So if it's running from a local machine, it takes the right image. If we run it in a GitLab pipeline, it also takes the right image, and it will work out of the box for both. And to show you what we win from this situation is, I also created the same part in a Docker file and also in a make file to get everything like the same. And I'm not sure, but Makefile, it's cool, but to be honest, I'm not the biggest fan of them. And yeah, I like it because I can write now everything in my Python code or TypeScript code, and it's more comfortable for us as a developer or as a platform team to use it in that way instead of writing Makefile or then also an external Docker file and so on. So that makes our life pretty easy on that. So let us have a look on that. Yeah, the Rust part is now compiling, and after that the deployment will happen, or not, because we didn't change anything on the code. So, but yeah, it will work. Yeah, that was a pretty easy, pretty straightforward, and in my opinion, absolutely interesting. And to be honest, after that experience, I'm a really Rust fan. It's amazing. It's really amazing. I love Rust and Dagger, of course.
There's many people in the community that agree with you. So I know that's why we have people in the community even building that Rust SDK. So thank you so much for this demo. I think it's always very helpful to have people come in and see how they're using it for their team specifically, and just trying to understand how Dagger can fit into their specific use case. So seeing things like this is really helpful, Patrick. Thank you again. Oh, Marcos came in with a question. How was your experience setting up the Rust caching in Dagger? Any interesting finds there?
To be honest, not really, because the hardest part was really to get everything up and running with the cross compilation. So that was the hardest part. And to be honest, we were totally happy after that. We saw, it's running. Yeah. That was a pretty hard learning curve for us. Yeah, to be honest, we didn't do that before. So actually, we didn't use the caching here explicit. Yeah.
Yeah, and just for the recording, Marcos was mentioning in chat that he recalled trying some Rust and Dagger, and for some reason was seeing that the compilation was being done each time, specifically caching the Rust cacher registry and the target folders. So Marcos was saying, let's chat about that more in Discord, which is a perfect plug again to the demo Discord forum, everyone. When I put this as a demo snippet, I'll definitely tag Patrick, and that way we can continue the conversation there. I think a lot of people in the community, especially our Rust fans, will be very interested in understanding. And then maybe, Patrick, we can even work on some type of guide or blog post.
Yeah.
So it'd be exciting.
Yeah, of course. I mean, it's cool. So yeah, let us do that.